olfactory ensheathing cells in facial nerve regeneration. Via ScienceDirect publication, Brazilian Journal of Otorhinolaryngology. Publication date, available online August 7, 2018. Source, Brazilian Journal of Otorhinolaryngology. Authors, Manyi, Qiubei, Jisheng. Abstract. Introduction. Olfactory ensheathing cell is a unique kind of glia cells, which can promote axon growth. Little is known about the differences between olfactory mucosa-olfactory ensheathing cells and olfactory bulb-olfactory ensheathing cells in the capability to promote nerve regeneration. Objective: to study the recovery of the rat facial nerve after olfactory ensheathing cell transplantation, and to compare the differences between the facial nerve regeneration of olfactory mucosa-olfactory ensheathing cells and olfactory bulb-olfactory ensheathing cells transplantation. Methods. Institutional ethical guideline was followed, 2015-10129A. Olfactory mucosa-olfactory ensheathing cells and olfactory bulb-olfactory ensheathing cells were cultured and harvested after 7 days in vitro. 36 Sprague-Dawley male rats were randomly divided into 3 different groups depending on the transplanting cells. Group A, olfactory mucosa-olfactory ensheathing cells. Group B, olfactory bulb-olfactory ensheathing cells. Group C, DF12 medium, fetal bovine serum. The main trunk of the facial nerve was transected and both stumps were inserted into a polylactic acid, chitosan conduit, then the transplanted cells were injected into the collagen in the conduits. After 4 and 8 weeks after the transplant, the rats of the 3 groups were scarified and the facial function score, facial nerve evoked potentials, histology analysis, and fluorescent retrograde tracing were tested and recorded, respectively, to evaluate the facial nerve regeneration and to analysis the differences among the 3 groups. Results. Olfactory ensheathing cells can promote the facial nerve regeneration. Compared with olfactory bulb-olfactory ensheathing cells, olfactory mucosa-olfactory ensheathing cells were more effective in promoting facial nerve regeneration, and this difference was more significant 8 weeks after the transplantation than 4 weeks. Conclusion. We discovered that olfactory ensheathing cells with nerve conduit could improve the facial nerve recovery, and the olfactory mucosa-olfactory ensheathing cells are more effective for facial nerve regeneration compared with olfactory bulb-olfactory ensheathing cells 8 weeks after the transplantation. These results could cast new light in the therapy of facial nerve defect, and furnish the foundation of autotransplantation of olfactory mucosa-olfactory ensheathing cells in periphery nerve injury.